start our second session, our second part of the afternoon session, and I get the honor of introducing Kelly. And so we have Dr. Kelly Turkington, who's with Agriculture and Agri-Food Canada. And Kelly was born in Humboldt, Saskatchewan, and raised mainly in Saskatoon, but spending the summers on his father's small farm near St. Through, Saskatchewan. Currently, he's the pathologist at AAFC's Lacombe Research Station in Lacombe, Alberta. He's got a Bachelor of Science degree in Agriculture Biology from 1985 and an MSc and PhD degrees in plant pathology from the Department of Biology at the U of S. He also spent 8 months taking a variety of courses at U of Guelph, so you've been in the East and in the West. So currently Kelly's main focus is on diseases of barley and wheat, while he also works on canola as part of collaborative studies with colleagues from across Canada. So we have 45 minutes, and hopefully there's time for questions at the end, but we'll watch that.
Well, thank you, Kim, for the introduction. It's a pleasure to be here. Hopefully I'll give you some food for thought. You might be wondering, well, geez, this guy's from Alberta. Fusarium head blight was never a problem there. It is now, unfortunately. But it's a disease issue that I first was exposed to in 1991 in Ottawa at the Ottawa Research Centre. I worked on a project there as a postdoc looking at the impact of tillage and crop rotation on Fusarium head blight in wheat and ear rot in corn. So I'm going to give you hopefully some food for thought, maybe some tips, and there'll be a fairly significant proportion of the presentation devoted to fungicide timing. And I think that's an area where we really have some opportunity to tweak things in terms of improving our ability to reduce the amount of FDK in harvested grain if it's wheat, and the amount of DON in a range of cereals. I don't work alone. I have some wonderful technical staff at Lacombe and some wonderful research collaborators both within Ag Canada, the universities across the Prairie region, and other research entities. We work closely with farmers, producer groups, industry colleagues, and so on. I wanted to specifically point out Randy Clear. He's retired. He used to be with the Grain Commission here in Winnipeg, and Randy and I worked on Fusarium head blight and especially Graminearum starting in about 1994-95 when we started to look for that particular pathogen in Alberta. So Randy has really been a very important mentor for me in terms of Fusarium and more the nature of the pathogen, its distribution, and so on. So one of the things that I like to sort of mention is that Fusarium head blight, from my perspective as a pathologist, I like to develop tools and strategies that are practical and that have a significant and positive impact for producers. But Fusarium head blight is one disease where it's been pretty difficult to get effective, highly effective tools in the hands of producers. So right now, you probably have heard that experts like myself advocate the use of an integrated approach. It's not a new concept. I was first introduced to it by Marcia McMullen with NDSU in Fargo, North Dakota, and that's been advocated, so it unfortunately hasn't resulted in really high levels of management. So the experience over the last 10 to 15 years, and I look to colleagues in Saskatchewan primarily, that northeastern part of Saskatchewan, where they've struggled to manage this disease issue. So they're following what the experts say. They're using that integrated approach. They're using a resistant variety, and I've got quotation marks there, and we'll touch on that in a few moments. They're avoiding host-on-host rotations, and they're using a fungicide. And unfortunately, when the weather is favorable and when they have a lot of Fusarium graminearum built up on crop residues within their field or the immediately adjacent field, they're still experiencing significant grade reductions and significant issues with DON, rejection for molting status, hog feed, and so on. So hopefully I'll give you a bit of food for thought. We're going to review a few things. There's some older stuff, but I think it's important to go back and look at what's been discovered in the past, and that has implications in terms of managing this issue currently. So if we look at the life cycle, I always like to talk about the disease cycle. So for Fusarium graminearum, it survives on crop residues. It is not a soil-borne pathogen per se. It doesn't survive in the soil by itself. If it's in the soil, it's associated with a piece of infected plant tissue. And it infects all parts of that cereal plant. The root system, the crown tissue, the stem tissue. We can find it associated with leaf tissue, and then of course the head tissue and the grain. In Alberta, we go back 20 years. Our focus, we looked at what was happening in Manitoba, looked at the big issue in 1993, the appearance of Fusarium graminearum in the southeastern Saskatchewan and crop districts 1 and 2 in the late 90s. And we were worried what is going to happen in Alberta. So at that time, one of the strategies that was advocated was to be cautious about your seed source. Graminearum, based on our surveying in fields, boots in the ground, was not a common pathogen to find. So one way to avoid that particular issue would be to look at seed source and avoiding planting seeds. Because the fungus will grow from the seed into the subcrown internode, into the crown tissue, and the research that we did in the early 2000s demonstrated it could go up to about the 3rd node in wheat and barley plants. So now you've produced a piece of infected residue. It won't necessarily result in epidemics of FHB the next year, but if you go back with a susceptible crop or a tight rotation, that residue and that level of infected residue will build up quite rapidly. So on that old residue, the key structure that the pathogen produces are the perithecia. And within the perithecia, you have the production of sacs containing ascospores. And they're literally shot up into the air like cannonballs. So they're carried from the stubble on the soil surface, from the perithecia, up by wind, currents, convective transfer, up onto the cereal heads, where they initiate the infections after head emergence. We're going to talk a bit about that in relation to fungicide timing. And then eventually, anywhere from 10 to 14 days later, depending on the level of susceptibility, the weather conditions, and so on, you'll have infected crop residue that's produced. One thing I want to point out is that those ascospores initiate the initial infection on the head tissue as soon as the head comes out of the boot. And then if it's wet, the fungus will infect, will grow, and it'll produce a second spore stage known as the conidial stage, or the macroconidia or microconidia for some Fusarium species. And that's rain splash dispersed. So what that might do is if you have wet conditions as you progress through the grain filling period, that will spread that fungus from that infected head or that part of that infected head to the rest of the head or adjacent heads, resulting in infections. May not produce symptoms like FDKs, but it's a superficial infection producing DON, which leads to rejection in terms of molting acceptability, hog feed, and so on. So if we look at strategies, one of the things that we can target is the residue itself, or perhaps the perithecia in preventing spore dispersal. So if we look at the residue, right now this really isn't of relevance other than maybe the Peace region in Alberta. Fusarium graminearum is still something that's not typically found or very commonly found. So seed infection is going to be an issue, so being cautious about your seed source, testing it, and so on will be important. But really across most of the prairie region now, the concern is more related to seed performance. Will that seed germinate? Will that seedling emerge? Will it have adequate stand establishment? So that's where seed testing by seed testing labs, seed treatment will ensure that that seed will perform as expected. Crop rotation with non-hosts is going to be an important strategy, and at least 2 years. So I say that as a plant pathologist, but there are many other factors that influence a producer's decisions in terms of crop rotation, comfort level with the crops, commodity prices, markets, etc. So I have to be mindful of that. So ideally, from a perspective of a pathologist, at least 2 years of a non-host crop. Residue management, tillage, and I've got a question mark there, and we're going to talk about that in a few moments. So using tillage to break up that residue, hopefully decompose it, and so on. Will that have a benefit? I'm not sure the research actually shows that, or the experience here in Manitoba going back to the mid-80s. Irrigation scheduling, if you're in the Outlook Irrigation District of Saskatchewan or in southern Alberta, that may help to limit the extent of infection of that plant tissue and thus a source of inoculum for subsequent growing seasons. So we're going to talk about crop rotation and we're going to talk about tillage. If we look at crop rotation, the typical rotation that we see most commonly across the prairie region from a pathologist perspective, and I want to emphasize that, is that it's not adequate enough. You're not deriving as much out of that rotation in terms of disease management as you could if you extended that rotational interval to allow for decomposition of that infected crop residue. But again, there are many factors that influence a producer's crop rotation decisions. I just want to emphasize, when the issue first started to be a concern in the early 2000s, there was a lot of misinformation in Alberta, including comments that corn, the Fusarium in corn was different than the Fusarium in small grain cereals like wheat and barley. Graminearum, that's absolutely not the case. It affects both crops, and if you look at corn production and recommendations to limit stalk rot and ear rot due to Graminearum or Gibberella Z, it's avoid planting on a small grain cereal crop that's had an issue with Fusarium graminearum. So the work done in Ontario, they first started to experience issues with this way back in the 80s, is that corn or maize was our biggest source of inoculum, and it was much more important than small grain cereal residue. In France, they looked at this in the late 60s, and again, similar picture. Corn was an important source of inoculum in terms of a previous crop, compared to something like common wheat, which would be equivalent to probably our CWS. Durum, though, was a significant potential source of inoculum. So highly susceptible crops, highly susceptible varieties within a crop type potentially can build up your amount of infected residue. So growing a variety that has at least an MR rating, it'll help to limit head infection and downgrading and DON, but it may also reduce the amount of infection in that crop and thus a potential source of infection. Now, what about tillage? And if we go back to some work done in the 1980s by Randy Clear and Don Abramson, a mycotoxin person with the Grain Commission in Winnipeg, the initial appearance of Fusarium graminearum and significant levels of DON occurred in fields under very much a conventional tillage regime, and I'll show you that in a few moments. Some retired colleagues of mine, Ginny Gilbert and Andy Takehouse, who used to work at the Ag Canada Centre here on campus before it was shut down and they decided to retire rather than move to Morden or Brandon. They looked at that watershed epidemic in 1993 in the Red River Valley, and they didn't find a relationship with the type of tillage system that was used. The project that I was involved with in Ontario, we really didn't have conclusive results, whether moldboard plowing or conventional sort of type of tillage or direct seeding had much of an impact. Ruth Dilmacki at the University of Minnesota also looked at this. They looked at moldboard plowing, chisel plowing, I don't know if that's like a lighter cultivation, and then direct seeding. And the disease levels in terms of severity of infection and DON didn't really reflect the amount of residue cover left by those different tillage types of systems. And then Art Shasma in Ontario with colleagues looked at relating the amount of DON in harvested grain and winter wheat with a variety of factors. The three factors that were most important: year, which is weather, crop rotation, and the variety. Tillage was not an overly important factor. So if we go back to that report from Randy and Don back in the mid-80s, and you look at the tillage system, it was disked in the fall and then again in the spring. I remember spending a lot of time on my dad's small grain cereal farm in the St. Brew Dalesford area on the tractor in the fall, pulling a tandem disc, breaking up the residue and so on. So it was disked twice. Pretty aggressive conventional tillage system, probably light tillage in the spring, harrow packing, and then seeding likely with a press drill. The key thing was the rotation. The one field had corn the immediate year, the other field had corn in part of the field the immediate year. So again, the importance of crop rotation and some of these more susceptible crop types in terms of being a source of inoculum. Just a bit of food for thought. I was at a meeting here a couple weeks ago in Saskatoon, and one of the questions that came up was, we've had dry conditions over the last several years. I haven't seen much Fusarium, I haven't seen much leaf disease in my cereal crops. Shouldn't this limit my risk in future years? Well, my answer is not necessarily. So you got to keep in mind that what you're seeing in the upper canopy and on the heads is what's happening in late June and early July. But if you've got moisture that has occurred in May, after emergence, seedling developed tillering, you can have some infection of the lower leaf and stem tissue, including by Fusarium graminearum. So that might maintain a very low level of inoculum in that field that then is available for future years. And in conjunction, if you have dry conditions, residue decomposition and disappearance of the source of inoculum is related to microbial activity, saprophytic fungi, bacteria that break down that crop residue, and that pathogen no longer has a home to survive on. So if it's dry, the level of microbial activity is reduced, the level of decomposition is reduced, and that residue potentially could persist for a longer period of time. One thing that we often don't think about, and the reason why I'm bringing this up is I've been to Australia a few times, and with blackleg and canola in Australia, one of the recommendations they have is field location. And the recommendation is to avoid planting your canola crop within 500 meters of a field that's had a significant level of blackleg the previous year. So if we look at Fusarium graminearum, we look at the research done, especially in Ontario and Quebec, back in the late 90s, early 2000s, most of those spores that are produced from, so these ascospores here, that are produced from the Parathecia will be dispersed, and they'll land within about 100 meters of the source. So it's immediately adjacent fields that are going to be most at risk. So if you've had an issue with Fusarium head blight, I'm going to move that ahead a bit here, in 2024, let's say, and you're thinking about planting a field immediately adjacent to it, you might want to think twice about that and may potentially consider moving or looking at a field a little further away to limit the exposure to the ascospores that are produced from that infected crop residue. So if we look at management strategies, so we've talked about reducing the amount of inoculum. We've talked about a bit about the role of seed infection and so on in terms of the source of disease in areas where the pathogen's not well established, as well as seed performance. Well, we can look at strategies that limit the amount of infection following head emergence. And one of the big ones here is going to be resistant varieties. And I have quotation marks. I differ from the breeders. They don't have resistant varieties. They have reduced susceptibility. So they're not immune from disease, and under highly favorable conditions, like 2016, for example, or 2024 in many areas of the eastern prairies, those MR varieties will still become infected, they'll still have issues with FDK and downgrading, and they will still have issues with DON. So if you're advising growers and they see in the variety guide an MR rating, and they think, well, that should control the disease like the MR for stripe rust or leaf rust. Totally different situation. With varieties of wheat that are MR or R to stripe rust or leaf rust, the genetics the breeders have incorporated, and the pathologists have helped them, by the way, are doing the heavy lifting. They're managing that risk to the point where you don't need to spray a fungicide. Not the case with Fusarium head blight, so have realistic expectations. Now in southern Alberta, in the Outlook Irrigation District, we did some work where if you limit the amount of irrigation as the crop is coming into head emergence, and for as long as possible post-head emergence, that will reduce or produce conditions that are less favorable for infection. The challenge is that if it's a dry year, you're also wanting to meet the water needs of that crop. So it's a bit of a careful balance there in terms of reducing risk, but you couple that with spraying a fungicide, an MR variety, maybe not growing wheat on wheat, that might actually have quite a benefit. And then fungicides. So this is where I'm going to spend a lot of the time, and then we'll finish off with some final thoughts in terms of other management strategies and then trying to pull things all together. So if we look at fungicides, it's suppression at best. And if we look at the research that's been done, a lot of the early work was done out of North Dakota. They looked at nozzle types, angled nozzles, and I'm not the expert. I don't know if Tom is in the audience right now. Okay, there he is. Listen to what Tom and his colleagues have to say at Sprayer 101. They're the experts. So the importance of head coverage. So you're targeting a vertical target versus more of a horizontal target with leaf tissue. And timing will be key issues in terms of coverage of that head. Now, expectations, the level of control. For FHB, typically less than 50%, and with Dawn, it can be even less. So not really high levels of control with fungicides. You compare that to tan spot or septorian wheat, net blotch, scald, spot blotch, and barley, you'd be disappointed if you're not getting 80% control, and it can sometimes be even higher with good application technology, good timing, and a good product. With the rust, typically we see at least 90 to 95% control. So with FHB, don't rely on fungicides only. Look at that integrated approach and pulling some of these other tools together to try and mitigate that. Now the other thing that I want to talk about is I hear this all the time, and maybe it's starting to change, but there's this fixation on anthesis and flowering. Infection can occur in the absence of anthers. Flowering is not as important as we think. The infection in wheat can occur anytime from head emergence through to the start of senescence. Depending on when that infection occurs, that's going to influence your severity of infection and the amount of dawn. So if the infection occurs closer to that flowering period, that's where you're going to get those high levels of dawn and that significant amount of downgrading due to the presence of Fusarium damaged kernels in that harvested grain. But infections can occur as you progress towards mid-milk, late milk, and to the start of senescence. Those later infections will be superficial. You won't see it, but when you test that grain for dawn, you will have levels of dawn above 1 part per million. 2006 in Manitoba, Andy and Jeannie were out surveying wheat and barley. And they were saying, it looks like a good year for producers. Not a lot of symptoms. Grain coming off in the river valley was grading a number 1, typically maybe a number 2 at best, number 3, number 4. That later infection resulted in limited FDK development, but when they tested the grain for dawn, so secondary quality control testing, it had levels of dawn above 1 part per million, and at levels that were not acceptable for hog feed, malting, human consumption, and so on. Very similar picture in the southeastern states with soft white spring in 2003. So dawn, basically, as soon as the infection occurs, right through to the start of senescence, that's the risk with dawn. So that adds an additional difficult element in terms of managing this disease. If it was only that infection around anthesis, that would be your primary target. Now, if we look at barley, we don't typically have huge issues with FDK. You don't get the same extent of shriveling and so on. And what you do get is a lot of discoloration. Sometimes you may even see perithecia development on that infected barley tissue. But if you look at later infections, that barley may actually appear healthy and bright, perfectly acceptable for malting status or hog feed. But if you test for dawn, it's well above 1 part per million. Could even be as high as 5 or 10 parts per million. So if we go back about 10 years, there was some work coming out of the States, and this really shifted my approach to recommendations, and I started incorporating that into some of the presentations I was giving in Alberta. Are the current timing recommendations too restrictive? So this was work done in Illinois, but it was done in other states. So if you look at that picture, you've got during check, you've got anthesis, or 2 days after anthesis, or 4 days or 6 days. You had Prosero and Caramba as our 2 products. And you can see anthesis was our ideal timing. But you can see with some of the later applications, including at 4 and 6 days, you weren't paying a penalty. In fact, there was some suggestion you were getting better suppression of Fusarium head blight, and a very similar picture for dawn. The red lines in both those pictures show you the point where you'd be getting at 50% control. So we're not even approaching 50% control in those studies. So if we look at some of the subsequent work, sorry, and if you can help, just get. I use the remote mouse instead of the other mouse. So if we look at the current recommendations, and this is from the Blue Book in Alberta, that's our guide to crop protection. So you have the Manitoba Guide to Crop Protection, Saskatchewan has their guide to crop protection. And if we look at that, the current recommendation in wheat is 75% head emergence, the start of the application window. In barley, it's actually 70% head emergence. So what does that mean? Well, that means in wheat, potentially 25% of those heads receive no fungicide, are totally unprotected. In barley, it's even worse, 30% of the heads. So let's look at some of the subsequent research. So we had a CAP barley cluster and a couple wheat cluster projects on Fusarium head blight management, including fungicide and fungicide timing. Unfortunately, it was during a period where we had fairly dry conditions, so the levels of disease were lower, the levels of dawn, but we'll show you some trends anyways. This is in barley, and it's AAC Synergy. And for the sites at Charlottetown, PEI, Melfort, Saskatchewan, we had sites in Normandy, Quebec. So most of our sites were in Saskatchewan, Brandon, Normandy, and Charlottetown. So at Charlottetown, there was a significant reduction in dawn with a late application. So the early application, we waited till about 1 to 2 days after full head emergence. The late application was 7 to 10 days after that. So that would have been outside the current window on the label. Very similar picture in Melfort. Normandin was a bit of a difference. The early application did a bit better. And I'm going to talk a bit about that because I think in terms of tweaking our response to some of the risk maps, that may dictate when we need to go into that crop, if it's soon after head emergence or if we can delay a bit. We also looked at Fusarium damage kernel severity. And I'm going to show you the sites where we had some significant treatment effects and significant levels of Fusarium. So at Melfort, with our check treatment, that blue bar, we had just under 0.4% FDK severity on a weight basis. That red arrow is at 0.25%. So that's the transition from a number 1 to a number 2. So with a single early application, a little bit better, not as good, but not statistically significantly different with the late. But our dual application, so going in 3 to 4 days after head emergence, so the start of anthesis, and then coming back in 7 to 10 days later and topping that up with another fungicide application. Oh, damn. My apologies. I'm going to stay away from that. Yep. Brandon, very low levels of FDK, but a bit of a trend. All of the fungicide treatments, didn't matter whether single early, single late, or dual, same response. Normandin, Quebec, our early single, our late single really didn't do much. It was the dual application that gave us our best suppression of FDK. Now, if we look at some other results, so Melfort in 2019, we had much higher levels of FDK, so above 1.5%. So we were into a number 4 CWRS. With a single early application, the red bar, we could bring that down to close to a number 2 CWRS. Late, similar, down to about just below 0.8% FDK on a weight basis, but it was our dual application that almost brought us from a CWS number 4 to a number 1, just above the threshold to a number 1. Scott, Saskatchewan, our early application single did quite well. The late application, not so much. So I think earlier application might be better for FDK. Dawn is a bit of a different story. Our dual application gave us our best response. And at Brandon, similar picture, but much lower levels of FDK. Our Dawn, we struggled with this in terms of our sites in the years, but Melfort, we had some levels of Dawn, and again, a similar picture to the FDK. Single early did quite well, single late, it reduced it below the check, but it was our dual application that gave us our best trend in terms of Dawn reduction. Now, one of the things that we did in one of our wheat trials is we looked at row spacing, and we looked at anywhere from 7 to 14-inch row spacing and a low and a high seeding rate. So the low and high was 200 and 400 seeds per meter squared. So you may be wondering what's happening here. So with our narrow row spacing and low seeding rate, you can imagine that seed row at a lower seeding rate, narrow row spacing, there's going to be larger spaces between individual seeds, so more potential for secondary tiller development. So that was our highest level of Dawn, about 1.5 parts per million. With our narrower spacing but a higher seeding rate, more competition between plants, less tiller development, and a narrower window for infection. With our wider row spacing, you're putting that seed, more of the seed within the individual rows. It really didn't matter whether we were using a narrow or a wide row spacing. So what about Dawn? Well, we had some high levels of Dawn. We were almost at 2 parts per million CWRS. It was AAC Brandon in that particular trial. We could bring that down significantly to just under 1 part per million with a single early application at that ideal timing. With the late, so 7 to 10 days after the start of anthesis, even a little better, but it was our dual application that gave us our best reduction, almost around 80%. So getting close to the level of control that we see with a fungicide for leaf spot diseases. Thanks. I'm going to use this one. I'm trying to point in the screen and I think, well, I'll advance with the mouse here, so my apologies. So what about some of the other data? So this is from Gursahib Singh and Randy Kuchar. Gursahib did his PhD with Randy. And they looked at sort of head emergence as a potential timing. They looked at the start of anthesis. They looked at anthesis about halfway. They looked at anthesis complete. They looked at a dual application, anthesis complete plus, anthesis plus early milk, so getting quite later. And you can see that trend of a reduction of Dawn as we went to later and later fungicide application timings. The one bar on the far right is actually fungicide at all 5 timings, which would not be an economic response, but a single application anywhere from growth stage 65, so anthesis halfway, and then up to anthesis complete, or even maybe a little bit beyond that, actually did quite well. What about the states? Well, Pierce Paul at Ohio State did a lot of work and pulled together a large number of results from a large number of trials. And overall, they looked at Caramba, they looked at Prosero, and the trend again, 50% head emergence, so roughly equivalent, close to that start of that current label window of application. We were maybe 25% control. We bumped that up to almost 50% control by going in at 50% early anthesis, and then 5 to 7 days after early anthesis was our best level of control. Very similar picture with Prosero. If we look at barley, Christina Calgar is a colleague in North Carolina. They have quite a significant craft brewing industry. They love to use locally sourced malt barley. They can't, because of Fusarium graminearum and Dawn issues. So they looked at timing. So they looked at untreated, that red bar. They looked at Prosero, they looked at Moravis Ace, and they looked at Caramba. And again, the same trend. The early application really compromised your level of control. The 100% head emergence improved it, but it was really 6 days after 100% head emergence. So getting towards the latter part of that label window or even beyond that. And more recently, Andrew Frischkopf, who some of you may know at NDSU in Fargo, did some work in barley and looked at Dawn. And some interesting results. So they looked at a range of trials and they had to group them according to what treatments they were using. So they looked at Prosero, so tebuconazole and prothioconazole. They looked at head emergence and they looked at late. So late was about 3 to 7 days after, depending on the trial, the location and year, after that particular growth stage. So much better reduction, so over 50% compared to about 15% control. They also looked at sequential application, and here they looked at head emergence with Prosero only, so that was just under 30% control. They looked at Prosero with Caramba, so Prosero at that head emergence, or that early stage, and then coming back in a little later. That gave us our 60% control. And then we looked at some of the other products, but Proline, so part of the Prosero combination, and Folicure Bracero, that's full, what is that, full follicule, that also did quite well. So if we look at some of the other work, they did some work with Mervis Ace, so they looked at Bracero at the head emergence, they looked at Caramba at head emergence, they looked at Mervis Ace at head emergence, and of the three, the Mervis Ace tended to give us our best response, but statistically Mervis Ace wasn't different than the Caramba. It was where they used sequential application, so that early stage, head emergence complete, and then coming back in anywhere from 3 to 7 days afterwards. So hopefully that's providing some indication that our current labels start too early. We've got much more flexibility towards the latter part of the label window, and in fact beyond that. So I'm going to start to wrap things up. So this is another extension piece from Andrew Friskoff. It was in their crop and pest update in late June of this year, and it shows you on the left-hand side of the screen wheat, and that middle head and the yellow arrows pointing to the start of anthesis, the yellow anthers. That big yellow line at the top shows you the window that is most effective for FHB and dawn suppression in wheat. In barley, you need to wait until full head emergence, and then you've got some flexibility beyond that. So if we look at pulling things together, and you're not dealing with just issues with Fusarium head blight, you're dealing with leaf disease issues. I'm not a big fan of the herbicide timing. I'm going to say that right now. Not the best target to be looking at. So if you're out scouting for your weed spectrum to figure out what actives to use, note what's in that crop. I did my PhD and master's in Sclerotinia and canola and petal testing and risk assessment. Sclerotinia and Fusarium head blight, you need to make that call to spray before you see symptoms. I love working with leaf diseases. You can follow what's happening in the crop with leaf disease development and use that to dictate if I need to spray and when I need to spray and potentially how often. So go back in at tillering, and as the upper canopy leaves, or as Nick Poole out of Australia says, the money leaves in terms of what's going to contribute most to grain filling and yield. And our rule of thumb is typically around flag leaf emergence. Look at that third leaf from the head. Do you see more than about 1 to 2% of the area of that leaf with symptoms of leaf disease? You're going to see a lot more lower down in the canopy. That's a clear indication that a threshold that you need to spray at that time. And then with Fusarium, we're relying on the risk maps, and Paul Bullock and colleagues that have developed that here at the U of M most recently. So if we look at 5 minutes, okay, we're going to go through this latter part really quickly. So that herbicide time, not the best target to focus on unless you're dealing with rust, biotrophic pathogens. We won't talk about that because I'll eat into my time. If we look at signs of early development of disease at herbicide timing throughout tillering, stem elongation, upper canopy leaves, that's a clear indication you're going to have to go in before head emergence at flag leaf, or potentially when the second or third leaf from the head are coming down. Key upper canopy leaves. If you don't see a lot of disease earlier on, tillering, stem elongation, flag leaf emergence, but things start to happen, you get a bit more moisture, that's a clear indication that you can wait and go in with a post-head emergence application, get your leaf disease control, and your FHB suppression. If in reality you're dealing with a complex of issues, leaf disease is FHB, so that's where you'll need to go in before head emergence if you have a lot of disease development, and then a little later on. So going back to the disease cycle, I just want to talk a bit about using the risk maps that Paul and colleagues have developed. And our focus is on infection, but it also, the parameters that are used in those models have relevance to the production of parathecia and ascospores. So if you look at that risk map, I recommend starting to follow it flag leaf emergence. Not when you want to spray for FHB, but at that stage, it's giving you an indication of whether conditions are conducive for parathecia development and, more importantly, ascospore production. So is the fungus going to be ready to infect that crop as soon after head emergence occurs? So if it's low right from flag leaf emergence through booting, through head emergence, that's going to be an indication where that risk is low. If it's high from flag through to head emergence, that's where you might want to go in soon after full head emergence to get your best level of control. If it transitions from low to high, from flag to head emergence, that's probably an indication where you could go in towards the latter part of the label window. And where things are really interesting is where it's high and then transitions to low. And there, I would look at the forecast for the next 2 weeks. I'd look at the risk aversion level of the producer and so on. So very quickly, harvest management strategies. The one thing I want to leave with you here very quickly, one strategy that producers use at the time of harvest is to adjust the combines to blow those FDKs out the back of the combine. Works well for wheat, not so much for barley and oat. Might help a bit, but not really a whole lot. The problem is that you're putting those FDKs back into the field. And those FDKs, that plant tissue is the most prolific producers of the perithecia and the ascospore stage. So you're just setting yourself up for a problem in subsequent years. What if I'm taking my crop for silage? So you're removing that head tissue, that could have an impact. Chaff collection, and one of the fellows from Washington State talked about weed seed destruction, destroying those FDKs and the weed seeds at the same time. Pulverizing, that might encourage decomposition. Just very quickly, why do I say that? Well, this is some work done in the late 80s or mid 80s in Ontario. John Sutton and a grad student in Congo. And they looked at comparing maize stems, maize kernels, wheat kernels, and maize kernels and wheat kernels were the most prolific producers of the perithecia. So if you're adjusting your combine to blow out those FDKs, you're putting back the most prolific producers of spores back into that field. So very quickly, I'll finish up here very quickly. In terms of straw, chop it as finely as possible. Spread it as much as possible. Encourage decomposition of that crop residue. And a couple minutes? I'm just about 1 minute. Okay, we're going to go through this. So combine fungicide application with these other strategies that I've outlined. That will help. Fungicide application can help. Keep in mind leaf disease risk, and that will dictate whether you need to go in before head emergence for leaf disease control and then again at head emergence, or if you can just go in at head emergence and get that dual protection. Optimal timing, I think, depends on the weather conditions prior to head emergence and the spore load, as well as after head emergence. And very quickly, utilize the latest in fungicide technology. The most critical thing there is getting that fungicide on that head tissue. Focus more on the mid to latter part of that application window. And going forward, I think we're probably going to see the introduction of later application stages, dual application, and that's going to involve a change in regulation, labels, and maybe actives that persist more for a longer period of time in that plant tissue. So with that, I'll end there. We don't have any time for questions, but there's my contact information. You can email me. I'm around for the rest of the afternoon. I fly back to Edmonton tomorrow morning, so I'd be happy to answer any questions at that time.
I think we'd have time for one question. Is there somebody in the audience that wants to ask a question quickly? Do we have anything? Oh, sorry.
I was just interested to know that the type of stubble does
Just
it...
wait, you have to speak in, we got 250
Thanks so much, Dr. Katie. So I was just wondering, does the type of the stubble, it influences the chemotype diversity of Fusarium graminearium?
That's a good question. So in Alberta, traditionally when we picked up graminearium, it used to be the 15-acetyl-DON chemotype. And then we started to see the emergence of the 3-acetyl-DON, especially in the Maritimes, especially in the Eastern Prairie region. The interesting thing is when we started to see discovery of graminearium outside of southern Alberta, invariably it was the 3-acetyl-DON and it was all small grain cereals. Southern Alberta, on corn, predominantly 15-acetyl-DON. So corn might be more favorable for the 15-acetyl-DON chemotype versus small grain cereals, which you tend to see more 3-acetyl-DON. Good question. Yeah.
Okay, thanks very much, Kelly. We have a token of our appreciation.